Hello friends, myself Rajendra Mahajan presenting my new video on multiplication by t raised to n theorem of Laplace transform. Its statement is like this: if Laplace of f of t as f bar of s given or we can obtain it, then Laplace transform of t raised to n into f of t is equals to minus 1 raised to n and nth derivative of f bar of s with respect to s. Once again I will repeat, it is minus 1 raised to n nth derivative with respect to s of f bar of s. F bar of s means the Laplace transform of that given f of t. This is the statement of that theorem. Then after knowing this theorem, we try to solve some problems. Find the Laplace transform of the following. First, t e raised to 8t, second t square sin 80, third, and like this. Therefore, we solve one by one. Watch the video up to end for better understanding, clear understanding. First, Laplace of t into e raised to 8t. Here we consider that f of t as e raised to 8t. Then taking Laplace or finding Laplace of that e raised to 8t as standard result 1 upon s minus a is here 8, and therefore it becomes 1 upon s minus 8 for the condition s greater than 8, and we call this as f bar of s. Say this is the first step. Then as it is multiplied by that term t, we take the help of that theorem. Therefore, Laplace transform of t multiplied by e raised to 8t is equals to, here the power of t is 1. Therefore, as per that theorem, the terms are minus 1 raised to n is 1, means minus 1 raised to 1, and the same order derivative means d by ds, first order derivative with respect to s of f bar of s, and that is equals to minus d by ds of the f bar of s is 1 upon s minus 8. It is 1 by x type of term whose derivative is minus 1 by x square, and as per that it is equals to minus of minus again 1 upon s minus 8 whole square. Minus minus it become plus, and therefore the answer is 1 upon s minus 8 whole square. This is the required Laplace transform of that function. Condition s greater than 8. This is the Laplace of t into e raised to 8t. Then we go for the second problem. We have to find the Laplace of t square into sin 80. Therefore, here we consider the function as f of t as sin 80. Therefore, f of t is equals to sin 80, whose Laplace transform is a standard result. Therefore, Laplace of sin 80 as a upon s square plus a square, a upon s square plus a square, and we call this as f bar of s. Say then second step, using that theorem, therefore Laplace transform of t square multiplied by sin 80. Here the power of n t is 2, therefore minus 1 raised to 2, and second order derivative d2 by ds square of f bar of s, and therefore it is minus 1 raised to even number, we get plus sign, and d2 by ds square we split as d by ds. Next step we split it, and what is f bar of s? It is a upon s square plus a square. Then splitting that second order derivative as d by ds of d by ds. A we take outside the operator, and the remaining terms are 1 upon s square plus a square. Means we have to differentiate this result twice with respect to s. A as it is, no change. D by ds also as it is. First order derivative of 1 by x is minus 1 by x square. Therefore, it is minus 1 upon s square plus a square and its square, bracket square. And then applying chain rule, derivative of s square is 2s. Therefore, minus 2a, constant term outside, and d by ds of remaining term. What is the remaining term? S upon s square plus a square and bracket square. Therefore, it is in the form of u by v, quotient rule. Therefore, we have to apply quotient rule to find out the next derivative. Therefore, minus 2a we keep as it is. Denominator term is s square plus a square whole square into derivative of numerator term. Derivative is 1 minus s. Derivative of the denominator term, it is 2 times s square plus a square, and chain rule, derivative of s square is 2s, and whole divided by the square of denominator term. Therefore, it becomes s square plus a square and raised to 4, square of square. Then we have to simplify it by taking s square plus a square common from that 2 terms of numerator term. Therefore, s square plus a square we take common. Remaining terms are s square plus a square remains in from the first, and from the second minus 4s square, and whole divided by s square plus a square raised to 4, bracket raised to 4. One term get cancelled, and therefore next step is minus 2a multiplied by s square minus 4s square, we get minus 3s square plus a square. We write down the positive term first, means it is a square minus 3s square divided by s square plus a square and whole raised to 3. This is the Laplace transform of that. Minus, we multiply it inside the bracket, we get 2a into 3s square minus a square whole divided by s square plus a square raised to 3 as a required answer. It is the Laplace of t square into sin 80. We go step by step to obtain this required answer. Then third, find Laplace of t multiplied by cos of 70. Here we consider the f of t as cos 70. Then we find its Laplace transform or known result by using known result, standard result. Laplace of cos 70 as s upon s square plus a square. It is a is 7 here, therefore it becomes s upon s square plus 7 square is 49, and we call this is a bar of s. Say, a first step is completed here. In second step, we have to apply the theorem. Therefore, Laplace of t into cos 70 is equals to minus 1 raised to 1, power is 1 here, d by ds, same order derivative of f bar of s, and therefore it is minus d by ds of f bar of s is s upon s square plus 49. It is s divided by s square plus 49. Again, it is in the form of u by v quotient. Therefore, we have to apply quotient rule to obtain the derivative. Therefore, term from denominator, it is s square plus 49 multiplied by derivative of s with respect to s, it is 1 minus s, and derivative of denominator term, it is 2s, and whole divided by the square of denominator, therefore s square plus 49, a bracket square. Then we simplify it, it is minus s square minus 2s square, we get minus s square, and plus 49 divided by s square plus 49 bracket raised to 2. And therefore, multiplying by minus sign inside, we get s square minus 49 whole divided by, in bracket, s square plus 49 and bracket square as the required answer. Or it is the Laplace of t into cos 70. Then, fourth example, example number 4. Find the Laplace of t square into sine hyperbolic 40. Therefore, function f of t is here sine hyperbolic 40. 4t. Then next step, finding the Laplace of this. Therefore, Laplace of f of t means the Laplace of sine hyperbolic 4t. Standard result, it is a is here 4. Therefore, its Laplace is 4 upon s square minus a square, 4 upon s square minus 4 square, and we call this as f bar of s. And then second step, applying that theorem to obtain Laplace of t square into sine hyperbolic of 4t. As power is 2 here, it is minus 1 raised to 2, and same order derivative with respect to s, that is second order derivative with respect to s of f bar of s. Then substituting the value of f bar of s, we get d2 by ds square, means second order derivative of 4 upon s square minus 16. Splitting that second order as d by ds of d by ds of 4 upon s square minus 16. 1 by x, derivative is minus 1 by x square. As per that rule, its derivative is d by ds of minus 4 upon bracket square, means s square minus 16 bracket square, and chain rule, derivative of s square is 2s. As it is function of function, always we have to apply chain rule. Therefore, it is minus 8 we take outside, and derivative of the remaining term with respect to s is s upon s square minus 16 bracket square. Then it is in the form of u by v. Therefore, applying quotient rule to find out this derivative. Minus 8 we keep as it is. Denominator term s square minus 16 bracket square. Derivative of s is 1 minus s. Derivative of this denominator term is 2 times s square minus 16, and chain rule, derivative of s square is 2s. We go step by step, then problem becomes very simple. If you jump any step, then it becomes somewhat difficult. Therefore, I am here performing step by step. Then once again taking s square minus 16 common from that two terms from the numerator, we get remaining terms as s square minus 16 remains from the first, and minus it is 4s square, and whole divided by s square minus 16 bracket raised to 4. One term get cancelled, and therefore remaining is minus 8 times s square minus 4s square, we get minus 3s square, and minus 16 whole divided by s square minus 16 raised to 3. One term get cancelled, therefore remaining is with power 3. S square minus 16 whole raised to 3. Then next, multiplying by minus inside, we get final answer as 8 times 3s square plus 16 whole divided by s square minus 16 and bracket raised to 3 as the required answer, or the required Laplace of that term is, function is t square into sine hyperbolic 4t. A required answer. Then last example, find Laplace of t multiplied by cos hyperbolic of 2t. Means here f of t is cos hyperbolic of 2t. Therefore let f of t as cos hyperbolic 2t. Then finding Laplace of this, Laplace of f of t means the Laplace of cos h2t. Applying standard result, we get its Laplace as s upon s square minus 2 square means 4. Here I have written 2 square. Next step I will write it as, or I have written as 4. And therefore, Laplace of that t multiplied by this cos hyperbolic of 2t using that theorem. Power is here 140, therefore minus 1 raised to 1. And same order derivative d by ds of f bar of s. And therefore it is minus d by ds. Laplace is s upon s square minus 4. Again in the form of u by v, therefore applying quotient rule to obtain this derivative. Minus as it is, denominator term is s square minus 4 into derivative of s is 1 minus s, derivative of s square minus 4 is 2s with respect to s, and whole divided by s square minus 4 bracket square. And simplify it, minus s square minus 2s square, we get minus s square and minus 4, and whole divided by s square minus 4 bracket square. Multiplying by minus inside, we get s square, it is the Laplace of t into cos hyperbolic of 2t as s square plus 4 divided by s square minus 4 whole square as a required answer. Therefore, in this video, I have discussed 5 different examples how we can apply that multiplication by t raised to n theorem. In next, I will discuss division by t theorem. Please like my video, share it, as well as subscribe to my channel. And to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.